our subject is gas dehydration. There are many ways to do gas dehydration. We select here two methods for dehydration. The first method is by absorption. In this method, we used chemical desiccant liquid glycol. The second one is by adsorption. So the first one absorption, the second one is adsorption. In this method, we use a solid substance, molecular safe for dehydration. Okay. As you know, we produced oil and gas depend from the reservoir. Depend on the classification of this reservoir. If it is gas only or gas cap water, gas cap oil water, or gas dissolved in oil, as we mentioned in previous lecture. When we produce from the reservoir a large amount of water come with our production. Then at the separator we separate oil and gas and water. The gas come out from the separator, pass through gas plant. The gas reach the gas plant contain a large amount of water vapor. In the gas plant, we remove the water vapor from the gas, and this operation called natural gas dehydration. So the natural gas dehydration is the process of removing water vapor from the gas stream to lower the dew point of the gas. The water vapor content of the gas is often expressed as its dew point. So what is the dew point is the temperature at which vapor begins to condense into a liquid at a particle system pressure. We can measure this dew point at field by using dew point tester. Just the gas in and the gas out, and read the thermometer, read here the temperature and read the pressure from the pressure of gauge pressure. Okay. This water causes several problems for downstream process and equipment. Like what? When we remove the water from the natural gas, we prevent formation of hydrate and condensation of free water in processing and transportation. And we require this dehydration to meet a water content specification. What the water content specification we mentioned in the table in the previous lecture. When we made a sale gas contract, there is a limit for water content in the gas, okay, and required the dehydration to prevent corrosion also, okay. let's go to see how we can remove the water from the gas. For the above reason, the gas process associations sets out a pipeline quality specification of the gas that the water content should be not exceed 7 pounds per million standard cubic feet. Remember that we put this number in our table in the sweetening of the gas. Okay. All right. Now look to this tower. Glycol dehydrator. First, the wet gas inlet to the scrubber. Then we feed the gas to the tower from the bottom of the tower upward, and we feed the lean glycol from the top of the tower downward. The lean glycol will contact with the gas, the wet gas here in this tower. First, we want to know about this tower. What look like is this tower? Even this tower has trays or package like that. This is bucket tower and this tray tower. The gas will flow from tray to tray to tray and contact with the glycol. Okay. This tray contain a bubble cups. What is the bubble cups look like? Okay. This the bubble cups. The gas flow into the bubble cup. It's forced to change its direction of flow, then pass through the slots in the base of the bubble cup before contacting with the glycol. And this case the gas to break into many tiny bubbles as it passes through the glycol. What is the purpose of this bubble cup? The purpose of this bubble cup is to increase the surface area and intimate contact between the glycol and gas. Okay, and H3. Also, we have a weir here. The function of this weir to hold back enough liquid so the slots of the bubble cup are always covered by liquid glycol. The glycol which flow over the weir passed down camera to the next tray. Okay, so the tray has many bubble cups, and this is the down camera to pass the glycol from tray to tray. Okay. All right. What is lean glycol? What do you mean by lean glycol? Lean glycol is the glycol without water. Okay, it's clean glycol. What do you mean by wet gas? Wet gas is the gas loaded by water vapor. Okay, first wet gas enter to inlet scrubber. This inlet scrubber like a filter. the natural gas enter in the inlet scrubber to remove all contaminants, like a small drop of oils, water, scales, and sand. For what reason? To avoid damage of the equipment. Okay? After the inlet scrubber, the gas will feed to the bottom of this contactor, flow upward, and contact with lean glycol to absorb the water from the gas. The dry gas leave the tower from the top. Here, another mist extractor to catch any smooth drop of glycol comes with the gas, with the dry gas. Okay. This dry gas must be as we request, specification of the gas. If not, we test it and bypass return to the tower. Again, we remember lean glycol, that means glycol without water, clean glycol. When the glycol absorb the water, he leave the tower from the bottom as a rich glycol. So the rich glycol means glycol loaded by water and some hydrocarbon. Okay. After that, the rich glycol feed to the flash tank. In this flash tank, we decrease the pressure, and some hydrocarbons release, and we use it. This hydrocarbon, we use it as fuel for operate in this plant, for the operation of this plant. Okay. After that, the rich glycol leave flash tank until this our heat exchanger to raise the temperature. Then another filter to avoid damage for this tower. Okay. Here the rich glycol feed to this strapper column and re-boiler. Here we must to stop for now some physical properties of the glycol. Okay. The glycol physical properties, in the first column we have monoethylene glycol, diethylene glycol, triethylene glycol, and tetraethylene glycol. If we see the boiling point in the first column is 386, and diethylene glycol is 473. Triethylene glycol, the boiling point is 548.6. Okay, we usually use this triethylene glycol. Okay. Now, when we feed the rich glycol to the strapper and the re-boiler here, if we raise the temperature to 480, what will happen here? The boiling point of the water is 100 degrees centigrade, right? when we raise the temperature until 500 Fahrenheit, just the water will release from the rich glycol, and the glycol will still as a liquid. So the water will release from the rich glycol, and we can collect it here as water vapor. The glycol will still at this temperature degree as a liquid. We can collect it in storage tank or storage drum. Okay. Return this clean or lean glycol now by this pump to the tower, and the circulation will continue. Okay. So the idea is very easy. It's control and the temperature until certain degree of temperature. We can release the water from the rich glycol, and the glycol will become lean glycol again. The different temperature between the wet gas inlet, the tower, and lean gas and lean glycol must be different by 10 degrees. Why? To avoid any condensation for the glycol. Okay, we can control by this temperature in this heat exchanger. Okay, I think it's the same with our previous lecture in gas sweetening chapter, if you remember. Okay, let's now go to some examples. Now, the summary of the glycol dehydration as follows. The wet inlet, the wet gas inlet from the bottom of the contactor, and the lean glycol inlet from the top of the contactor. Then the lean glycol will absorb the water from the gas. The dry gas will release from the top of this contactor. The rich glycol, which loaded by water, leave from the bottom of the tower and feed to the strapper and brief boiler. Here we can control by the temperature to remain our glycol as liquid. The water release from the glycol as water vapor, and the glycol collect as lean glycol in this tank. Then we pump it, and by this pump the lean glycol again to the tower, and the circulation will continue. Okay, let's see the exercise for this subject. A dehydration plant is designed to remove water from 50 million cubic feet per day. Pressure is 750 psi. Temperature 95 Fahrenheit. The outlet gas, dry gas, contain 7 pounds per million cubic feet. How much water is removed daily in this contactor? Okay, to solve this problem, we must to see this pressure, inlet pressure. The inlet pressure is 750 psi. So we must to add here 14.7 psi. Okay, so you have pressure and temperature. Just go to the chart at 95 degree Fahrenheit. and due to the pressure at 764, and read how many pound water per million standard cubic feet of the gas. Okay, so the result is 67 pound per million cubic feet. Now we take this 67 pound per million cubic feet minus 7 pound per million cubic feet is 60. Now water removed per day equal 50 million cubic feet per day multiplied by 60 pounds per million cubic feet by million cubic feet. So the million cubic feet will remove with million cubic feet, and the result is 3,000 pounds per day. So how much water is removed daily is 3,000 pounds of water per day. Okay, it's very easy. Thank you.